So today we're going to be looking at one of my favorite topics again, confidence intervals. Now, this is slightly different to what you do in methods. We use a slightly different formula. It looks like this. Now, this is the one that is given to you on your QCAA formula sheet in your exams. So over here, we've got our little formula. So this part here stands for the mean. This part here is your Z-score, which is based on your confidence interval percentage. This is your standard deviation, and N is the number of scores in the sample. So let's start looking at our question. Now, I'm going to be highlighting some stuff in between here. Let's go with yellow. Okay, so after surveying 20 people in your class, you find that they plan to spend on average, an average of this amount on their lunch today. The standard deviation for your sample was this much. Use the statistics to state a 95% confidence interval for the average amount that they will spend on their lunch today. So let's start noting down some important information here. Now, I'm going to list all of the variables that I have in my formula. So I've got the mean, I've got our Z-score, I've got our standard deviation, and the number in the sample. So our average is 4.53. Our Z-score is 95% confidence, which means, that doesn't look like an arrow, that looks like a 7, which means that our Z-score is going to be equal to 1.96. Now, if we weren't given the Z-score and we needed to find it, because obviously you guys don't remember this like I do, all you have to do is go to statistics. You want to go to, let's see, distribution, normal distribution. Then you're going to click on the inverse normal. You're going to set your data to variable. The tail is going to be central. Your area is going to be the area that's stated in the question, but as a decimal. The standard deviation, because we're trying to find the Z-score there, you set it to 1 and your mean is equal to 0. And that's how you find your Z-score. Okay, so standard deviation is given to us in the question is 0.23, and lucky last thing is there are 20 people in the sample. So all I have to do to find my confidence interval is chuck it into this formula. So CI, which stands for confidence interval, is equal to the mean minus your Z-score multiplied by your standard deviation divided by the square root of the number in the sample, comma, because this is a range. The mean again, this time we're plussing it. So you can see there are some similarities to the formula that we use in methods, but you don't use this in methods, you use a different thing, which is how these two formulas are going to be different. Okay, there we go. So now I'm going to infill that with my numbers, minus 1.96, 0.23 over 20, comma, 4.53 minus 1.96, bracket, plus, that should be a plus, 0.23 divided by square root of 20. Okay, so once you plug that into the calculator, you're going to get the answers of $4.43 for your lower confidence interval and $4.63 for your upper confidence interval. Now, I know what you're thinking. That seemed like it was pretty easy, but there is an even easier way of doing this. So what we're going to do is we're going to get our calculators out. We want to get our graphics calculators. If you just let me flick through here and I'll find it. Now, this is the old school calculator, so it does look slightly different. But what we're going to do is we're going to go menu, statistics, intra, and Z. Then we're going to go one sample, so that's that one. Now it comes up with this. Now this is a way of us predicting the confidence interval without having to convert to z-scores. This is going to take it just as the confidence thing that it is. So first thing I want to do is I want to change the data to variable. Then the confidence interval, we want it to be a confidence interval of 95%, so I'm going to leave that one. Our standard deviation here is 0.23, and our mean is 4.53, and there are 20 numbers in the sample. Now, that is going to give me my confidence interval. There you go. There's the lower and there's the upper.